Hello, my dear friends on the internet, and welcome to another coding session where I'll be continuing on the basically the programming language that I was making so far. So hopefully it will be a bit more boring today than last time. But yeah, boring or not, suffering is one of the key objectives that we want to achieve, right? So yeah, without further delay, we can actually get started. And by getting started, I tried to say is that last time, if I remember correctly, right, we had something like an assignment statement, right? This kind of an assignment statement where it boiled down to something like this, right? While it's technically possible, I didn't like this one. There are two major reasons. So one of them is, if I can spell correctly, so plus Parser, is that like it's a bit hacky in my opinion, right? And second of all, we're creating some blank items, right? We're creating some blank tokens which are not part of the ASP themselves. So rather, I would like to go through the same way as like this other things go, right? So that will actually be a bit easier if we just like deal with things a bit differently, right? So what our current code is when we are parsing a statement, right? We are parsing one term, and then we're looking at the next operator, and after looking at the next operator, based on the next operator, we are deciding whether we are going for a assignment operation or we are going for let's say an expression parsing. When the logic is correct, I want this logic to be inside assignment itself, right? And that way we can actually like get rid of this extra junk, right? This is look, this is not going to bite us that much, but think of it this way: like for every statement, I am creating a term, right, which I'm not using or extra token. And one thing I can do is I can track how many tokens were there before I created this and remove the last tokens, right? But let's try to do that way that I just told you, right? So when we are parsing a statement, right, we can always come back to the old ways. But for now, this is a hard decision because like you built on something and then you just delete it. So we'll not rather do that. What we will rather do that is we'll just move this code to rough. So if things go south, we can always like get back to where we were, right? So I'll just cut this thing for now, and I will paste it here, right? Something like that, so that we don't lose this thing. Because, the purpose of rough is there. But the way I am thinking of handling statement is this: a statement is nothing but a term followed by some equal to symbol, followed by some not statement but an assigned statement or assignment, right? We call this assignment. So an assignment can be a term followed by an assignment, right? Or it can simply be an expression. So that's the goal, right? So this covers everything because this expression can substitute this assignment, and this assignment can unfold into multiple assignments. And because we have a left term, we're fine. And the similar way, our statement can then become just an assignment, right? No ambiguity. And then for a expression, we already have that cascading thing going on, right? So I think that is a much more clearer picture than what we are doing here. Like that is something more expectable to me as a design decision. So let's do that. Let's keep this statement as it is, but rather we can just do something like this. So basically, auto assignment is equals to parse assignment, right? And once that assignment is parsed, we can basically say that whatever our statement node is, add it to its children, and let's move forward. So that's what essentially our statement becomes. And the role of deciding this thing falls onto the assignment itself. So let's try doing that. Let's cut this guy. Just to be safe, we can also put a copy here. Although I don't think that we will need to restore stuff for now. But yeah, it should be here, right? Parse assignment. And after this part is correct. No, not this part is correct. But let's skip this thing, right? So it's more like now these guys, like one of these guys, right? So like parse factor, for example. So you can just get this guy, right? And you can modify this accordingly. That will be one way of dealing things. And that will be how we will be doing this, I think. So yeah, a bit of copy pasting will be involved. But all things considered, we should be fine. Right. So this is our new parse assignment. Let's forget about this guy. Right. So instead of parse factor, from now on we will call you parse assignment. Right. And the first thing is a term, which we all agree. Right. Like we parse a term. But next is this part, right? Where basically what I'm saying is that it can be an assignment or not, right? So we can call it as assign expression, right? Something like that. So basically we can have an if statement right here that if if the next token, right? So current dot value is equals to this symbol. That means we are doing some kind of assignment, right? And I'm still against doing multi assignment, so we'll see, right? So if this is the case, right, and more cases might come, but if this is the case, that is a simple assignment. Actually, these are all of same precedence. I can see, right? So we can add all of them as a same precedence, right? And either this is the truth, right, or whatever our current token is, right, its value and dot size is equals to 2, and the second token is basically our assignment statement. That's what I'm going for. So basically this, and like current dot value dot data 1 is equals to, like, because this is a character string, so I think this is a valid assumption to do, right? And yeah, this is a double equals to, so this is a comparison, right? And we can move this a bit to have some space. And that's fine. So if this is the scenario, right, that means we are dealing with some kind of assignment. So the simplest thing will be to do is this guy, right? So I'll first work with the assignment itself. So I'll just say that while like this guy basically. So while, if I can type correctly, our like current dot value is equals to assignment, right? Uh, then again here also that yeah, we can basically dilute it. If this is not a statement, we will restore the stack. So maybe I'll just take the whatever the size is. So maybe size p pause is something like underscore TK cursor. And also size t, our basically whatever the amount of tokens we have, right? Because if we don't find this assignment operator, we'll fall back to statement basically. So size t, like nodes count, like it will be equals to whatever our AST is. It's nodes dot size, right? This gives us like how many nodes we might have, for example. And now, if this is not the scenario, right? If this is not the scenario where there is no assignment going on, we can simply restore the whole thing, right? You can simply say that it's fine. Don't worry about it. Our current pause, like our cursor, is still equals to current pause, right? And while our AST dot nodes dot size is greater than whatever our node count was, right? We are going to pop those nodes. So basically, mm, like AST dot nodes dot pop back, right? So that way we maintain that kind of thing, right? And now goes to this assign expression, right? So that's pretty much simple. If we have an assign expression, right? So first of all, we need to create the new node. So auto new assignment is equals to ast dot create node, right? We don't know what kind of node it is, and then we can check, right? We can say that if our already an assignment expression exists, right? In that case, our term is itself the assignment operation, maybe. So term is equals to like how we are used to do, right? Yeah, and then although I am not like 100% sure that this is the right way to go, but yeah, let's check. You can always get back to it, and then you can start on if and other statements. So that is one thing. And the second thing is like this part, right? So basically, we are saying that whatever our assignment statement is or whatever our like that, like if we already have an assignment statement, right? If you already have an assignment statement, yeah, it doesn't really matter. We will see that when we see the output. For now, we can just say that our new assignment, right? It's children dot push back our year, basically our term, right? So that is the first thing. And the second thing is that whatever our new assignment is, right? If I can spell it correct, its value is actually an assignment, right? So it's basically assignment, or basically this symbol, right? And here we have not like eaten anything. So basically our symbol we can eat after doing this. So current that value, right? Because that's the symbol. And then we can say that okay, we have written this value. We can maybe um we can maybe implement this thing, right? So we're done with this token. And once we're done with this token, the next part is this, right? So basically new assignment is equals to, or if we just remove this while, what will happen, right? Because recursively we should get to the same thing. I'm just wondering. So new assignment, let's say new assignment is equals to like basically auto term two is equals to parse assignment. This is what I'm trying to say, right? So here we get the term two, and then we can do the same thing, like whatever our new assignment is, it's term two, like children dot push back term two, right? And then we can simply return it. I'm just trying this. If this works, then that's it, right? And we don't do this thing. We don't care about this. We just create the new assignment and we return it. I'm just thinking. And we also don't need assigns expression in this case, right? But else, if that's not the case, right? We want this part as well, right? So else, first of all, we clear previous tokens, right? And then what we basically do is we return a parse expression, right? Well, it was not an it didn't had an assignment symbol, so it must have been an expression. That was basically the idea. Or in this case, it was a term and then followed by an assignment kind of thing, right? So if we just have that, right, and nothing else, what kind of results are we going to? Will our compilation fail? No. And then let's look at this thing, right? So z equals to x equals to y equals to some expression that was here, right? So here also you can see we have an assignment where z is assigned to some other assignment, where x is assigned to some other assignment, which is y, which is assigned to an expression where basically you add 2 plus 2 and 1 first, which is basically happening here, and then you do a multiplication with 5, right? So which is basically happening here, and then this whole thing you basically subtracting from this, right? And if you look at the second thing, like this plus equals to z plus equals to 20 plus so on, that is also like done here quite nicely, right? So where is it? This thing, like this is a classical statement where you're basically assigning z to this whole expression, and that basically saves us some more statements, okay, like these things. And we can in the later stage we can have support for different types. For now, even if we remove this change, nothing else changes, and that means we can remove this folder of code as well. and suddenly it becomes much more clearer than it was before. Right. Now, I think that we are at a point where we have the basic expressions done. So, and I would like to have our AST modified a bit. So, I think we have some redundant operations in our AST that I don't like. We are not using here at this moment, right? For example, like if we search here, right, if we search for like AST expression, so like in the here there is an AST expression, but here there is no match. In this file there is no match, right? So that's what I'm trying to say. Like here, if we try to go next, there is no match. So AST expression is kind of redundant, right? And the same goes for these operations, right? Because these all I can think that this will fall under assignment operation. That's my ideas, right? And that does not cause any issue here as well, I guess. At least, yeah, it doesn't cause any issue. Rather, what we can do is we can have something like this, right? Where is it? In the assignment itself, like wherever we are passing that assignment. So, so yeah, in the pass assignment itself, what we can do is we can like where we are creating the node, all right? We can create an like AST assignment. Okay. And also, I need to check how many places I'm creating some kind of a like blank node. Okay, so this is one way, right? Where I'm passing everything in parse factor, but I'm not doing it properly. So this node's type is not right, right? So we'll put like is the okay. We are setting the type later. Then that's fine. Then that's fine. As long as we are setting the type, then that's fine, right? And here also you can deal with other same precedent like explanation things. Uh, but yeah, let's now do a different thing, which is parsing a function call, right? And parsing a function call is most likely going to go inside parse term itself, right? And how we are going to do it is this ID thing, right? It can become much more complicated than this, right? So what I would probably want is to have a parse ID separately, like, and then use that parse ID there. So AST node p pointer parse ID, right? Something like that. And so basically, at this point, we know that we have an ID, right? So we can let me just think for a bit that I can come with a better approach because we need to not only support function calls, but we need to support those guys as well. Like for example, so here we can simply return parse ID, right? So let this be here for now at least, right? And let's return the node if I can spell correctly. And here we can just simply return parse ID, right? And then we can just, like, for example, do this, right? And everything is somehow correctly. What is it called? Aligned, right? So let's go to our rough, right? Let's go to our rough, And let's see like the operations of the functions. Right? So a function call has much more precedence than an substring operation. So that means that makes more sense, right? Because basically you have some ID, right? And then you have some function call, basically like this. And here you have some args, right? So arg1, arg2, and such one, right? Something like that. Then followed by this is you have something like this. So while this is a variance that can occur, and here also you can have something like an ID of some arg, for example. This is a total valid statement in my opinion. And the second thing that might occur is you have an ID where you have something like this here, ID of arg, something like that. And then followed by this, hey, right? Hey man, I see you again. Last time I saw you came. Are you a subscriber of me or something? Maybe I don't know. And then you have like arg1 and arg2. I can't spell your name. Okay, you know the reason why. But yeah, hey man, I can write hey man. So yeah, I don't know if you are a boy or a girl, but like for me, a man is just a human. Okay, there's no gender associated with it. Mm, but let me just think for a few seconds, and I think I will get to something good. So, mm, what I am thinking is that we can have something like this guy, right? This guy's here. We can have something like that. In fact, I think. So yeah. Before that, let's get the easy thing done, right? Which is an argument list, right? So so basically we can have like for example if we go to AST, we have a AST call, but AST call will need AST args or call args, right? Because call arguments are different than when you're declaring a function, right? We don't have any function declaration right now, so let's go with that. So let's go with args first because I think it's much more simple, right? So AST node p pointer parse call args, something like that, right? And call args are basically simple because all you have is like you have either an expression, right? So like you have one or more expressions, right? So first of all, we will eat, right? And or okay, let's keep the like these braces out of the arguments. The arguments are just like comma separated lists, right? So we'll just call it AHT args for now. Okay, we can look at it later. Okay, we so slash this. Okay, so yeah, so what we do, we first pass the term. So auto mm, or expression is equals to parse expression. Right. And once we have an expression, we can check if while current dot. So if we have more than one, right? So if like we have some kind of comma, right? Then we will have more than one, right? But we can have a parent node where we can just directly put this expression on. So maybe that we'll do that auto. So args is equals to ast dot create a node ast args. Okay, we'll not call this call args, but we will call this args for now. Here also we'll just call it ast args. Right. And the first child will be this expression, right? Or it might not have any expression at all, right? So that thing we need to check, right? So if current, like, that's one thing that makes me okay. So arguments will have a bracket. I have changed my mind, right? So first of all, we will eat, right? You cannot like keep arguments without a bracket. I want to keep things simple for myself as well. Later we can you can do all the things. So we'll first eat this guy, right? So you're going down, right? And then we have this arcs, right? And then while basically whatever our current token is, its value is not equals to our this guy, right? So whenever we, as long as we are not getting this guy, we are basically going to get an expression, right? And then we will basically push like args dot children dot push. Actually, args is a pointer, so args children dot push back our expression, right? And if we don't get like if current dot basically value current value should now be equals to this, right? Equals to a comma, right? Because it's a comma separated list. But what happens is that what happens if we're not having a comma, right? In that case, we'll simply break because we have only one child. Okay, and because now the current value is this guy, right? So we will expect to eat this guy. Okay. If anything else comes, that means we have encountered some kind of error. That basically means. But if it's not that, and it's indeed it's actually not equals to, right? So if it's not that, that means that we have basically have another argument, right? So we can eat our comma with grace, and then we can just go on doing the same thing, right? We can go back to doing passing the next expression because it's not going to be this, and so on, right? And if it's the last thing, right? If it's the last comma, in that case, it's fine. Like even if we can support last comma. Okay. And sometimes I feel like having the last comma makes sense. Sometimes I don't. So that's typically me. But once we're done, you can basically return the args. Right. So I think this will do for now. Right. This will give me all the args I need. Mm, and yeah, the next thing I would like to do is get these guys out, like these simple guys out. Right. So that we can do very fast. So we can call them something like the base token or like the primary token. Let's go for primary. So AHT, because I think it's actually called primary. I don't know. So parse primary, something like that. Right. So in case of primary, all we need to do is this. Right. Right. So or it can also be an identifier. Right. Actually, we can have this whole thing. Right. So a primary can also be an identifier, most likely. So let's add this thing. It's one single part of it. So PKID. Basically. This will be like AST var, right? And we can also have like, for example, strings, right? Because why not? Maybe string should go up. So we can do this one string. So PKSTR, right? In that case, we have something like an AST STR, and yeah, we have our strings as well. How cool is that? And every time in all the cases we are doing this, right? And if none of these are true, right? So else um, you can raise an exception saying that unknown find something unexpected token or something like that. Right, token. Let's say the I don't know if it will blow up current um current dot value. I think this will fail because yeah, this will fail. So string message is equals to this, right? And then message plus equals to current dot value. This is going to work. Let's have a space here. And yeah, this is message, right? So if none of these are true, in that case, in fact, we are going to say this. And in that case also, we are going to, although here the program will end itself, but still just add a null pointer here. All right. So that's about parsing our primary expression, right? So then comes like this thing. We have parse arguments, but I would rather call this like it has some ID followed by something, right? Some identifier followed by something. So we can call this something like parse, maybe postfix or something like that, right? So let's go with that. And call this this parse ID is not being used, right? Anyway, if I'm correct, right? And in parse term, we are going to basically okay, parse term is already there, so we can just do all that you want to do in parse term itself. That will be better, right? So we know that we have a primary going on here, right? So let's say auto primary is equals to parse primary, right? And recursive descent, when writing a descent, the best thing about writing a recursive descent person is that you have a good exercise about doing recursion. Yeah. So hey brother, I'm from science stream and don't know shit about programming. Is this for me? For Vibe, yes. For as far as programming is concerned, what I'm trying to make is a language which you can. start learning once you are like if you're in learning about computer science, right? But a language is essentially a way create an abstraction, some kind of a grammar that can be followed to make something human readable, which then program or an application can take and convert into some machine code that then it can run. So the short answer is no, unless you are from computer science and you have like basic understanding of how a, a program or an application works, or like what basic programming is. I don't think it's for you. For vibe, yes, but no. Mm, that's about it because we are not discussing concepts. Even if we discuss concepts, like languages are not like I don't think like unless you have been to computer science, it makes any sense to discuss how to create a language, right? So you can think of it like this, like pattern matching, different kind of grammars allowing them, but still, like if you don't have a understanding of language and we're writing a language using a language, so I don't think it makes sense. But yeah, like if you want to talk about physics or like in general machine learning or things like which are math dependent, I don't usually make machine learning related videos is due to because of the fact that that is part of my daily job, so I don't want to get any conflict there, right? Because many things that you do are proprietary to your work, so you don't want them to think that okay you are doing that proprietary thing outside, even though like you are not doing those proprietary things outside. So probably I need to talk with them and like get permissions that I will do if like we get a good kind of crowd, which I clearly lack right now. So yeah, when that time comes, we'll see. And for you, Chandras, I think like it will be a wastage of time. If you're in science stream, if you're doing your like higher secondaries, I would suggest you sit down, do some maths, do some studies. And that will be most crucial because this is the time that you will be missing for your entire life. You'll regret that, okay, I didn't study harder just for 1 hour more for your entire life. Okay. So don't do that. And just think like I like you can think of it a bit of flexing. But I'm not actually, but like one of the happiest ever moments that I have lived in my life is like when my HS results came out and I got like 99 in maths out of 100. Okay, getting 100 out of 100 in your like 10th exam is a different thing, but like getting on your 12th exam 99, it was crazy for me. Like after me, the next score was 94 or 95 something in my school. So yeah, it meant a lot to me. Like it meant to me that yes, I didn't like all my work didn't went to complete them. So yeah, let's get back to topic now. All right. So yeah, we are going to so if it's not an ID, right? So so part primary is fine. We can for now just return primary, right? If I can spell correctly. But apart from that, we can just put a type check on if this primary expression is containing some kind of ID, right? Because if it's an AST var, right, and in that case, I want to go a bit further and check out what next tokens are probably. So that's what we're going to do. We'll just simply check if our primary, whatever it is, its value is like not value but type is like AST var, right? That means I have a variable, and after this variable, I'm going to have some kind of like some kind of either call or some kind of um, like how do I say, like some kind of indexing, right? So while you can have a while loop, right? Basically, and you can check if our current token, its value is equals to one of these guys. Either it might be this, because both the scenarios, if we go to our rough, right, you can see that like both the scenarios are possible, right? So we need to treat both the scenarios equally. That's what I'm thinking. Right. Yeah. So if it's this guy, or if it's the other guy, right? So current dot value is equals to this guy, right? That means we have something in our hand that we now need to handle. So first of all, we need to know that what symbol we need to do. So we can just have two branches, right? Although like you would say that why are you like after a while you're putting an if and you're putting the same statement, but that's fine here. You can always come back, do some clever stuff, and like raise the bar so that nobody can understand our code except ourselves. But like in a real scenario, you don't want to do those kind of like fancy stuff. Hello, bro, Pranjal. Are you the Pranjal that I know? Because I had a junior called Pranjal. I don't know if you are him. When I was doing my masters, I had a junior called Pranjal. But yeah, hello, bro. So current dot value. So current dot value is equals to this guy, right? This is our second scenario, basically. Then we want to do something. We can even put else, right? Because only these two branches are going to be originated from this parent while. And in this branch, what we're basically going to do is we're going to parse our um, this thing. We're going to call parse args. Okay. We're going to call parse args. Because parse args will take care of eating this guy, and eating all the things in minute. Right. So we can say that so basically auto args is equals to parse args. Right. And then maybe in primary dot type has now been converted to a call. Okay, because we have now arguments available. And now primary I think primary is a pointer, right? So we should respect that. And then primary, if I can spell correctly, children has our argument. So push back or something like that, right? And then with that we can basically have like a lot of them, right? So I'm thinking, yeah, we can do this. We can come back. But in that case, like when the next time comes, right, we get the args. Okay, I have a good idea. Let's not do that. Let's do this way. So we have args, right? And then we have auto call, right? And call is nothing but our AST dot create node AST call, right? And call will have two children. One will be our who is the first guy, so our primary, and then the second, actually, this will be call, right? Last thing you want to do is like put primary as a primary children. So the second thing I will do is call children dot pushback, not power back, but pushback our args, right? And then our primary will essentially become our call. If that makes any sense. I don't know. Maybe we'll see. So that's about this, right? And now let's go for our this part of the picture, right? Where we are encountering not this. Not sure. This is my bad. Well, this can be encountered. I'm not saying that it can't be encountered, but right now we are not going to encounter this by anyway. Right. So this is this also I will just keep away, right, as a separate function. Something like parse args. So let's just copy this. So we'll just yank this. We'll paste it here, right? And we'll call it parse. What do you call it? Parse index, parse subscript, parse subscript maybe, because we're indexing something. Parse subscript is fine, I guess. So yeah, in this case, we are going to allow everything. In fact, I think that I would I'd like to have at some point of time Python like list comprehension and those guys, right? Or like at least basic like slicing. But for now, we will keep things simple. We'll just have this. But I will support multiple commas. No, I'm not going to support multiple commas. So I'm going to eat this. Then I'm going to take an expression, right? So or we can do something cool. We can right away support this, right? Mm, 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 mm. Yeah. So this time we'll look for this guy, right? This is our full that Python range separator, right? So instead of comma, we can have an expression followed by this thing, followed by mm, this thing, and so on. And then in some later stage, we can verify just to support this syntax. I don't know. We'll see. So yeah, that's about it. Um, but we need to have a new type, node type, right? So let's check in AST. And in AST, we have calls, we have args, and then we can have AST subscript, something like that. And this guy, this friend of ours, will become an AST subscript, I guess. I don't know, like what is it called? I think it's called subscript. So AST subscript, yes, because subtraction is there. And then we return this. So we call this sub, no, just to be like not confused. While copy paste is good, it's not that good. Um, yeah, so that's good. This will also be subnode. Subnode will contain multiple children and so on. And so here basically ideally it should be able to do something like same thing what we have done here, right? So you can just copy this guy, right? And you can paste it here, right? But instead of args, we will have like sub, right? So sub um, subscript maybe. Then this will be sub, right? That's essentially a new parse system where we can have a parse primary, but then if the type is var and we get any of these guys, right? We get any of these guys, then we will continuously do this. And once we have built out that expression, then we're going to return the primary. So now, time for some drum roll because we are going to test. So what I would like to do is maybe I would like to let's see, control key, control shift P, um, duplicate panel split. Okay, this is not what I want. Control shift P, close buffer. Okay, it did nothing. Anyways, CD sparrow person really matters. And nvim example demo, right? So here we can start trying for our different types of expression, right? So first thing I want to do is I want to have something like this. So printf hello world, right? Something like percentile backslash n, right? So does this work? Let's check it out. So make and make run, right? So we have a statement where basically we have printf, right? And then we have hello world. So this is because this is a call, right? And this is an argument list where we have one argument that is hello world, right? But you can have something like this, like one and then let's say 2 plus 4 times one plus two, maybe 1 plus 2. Yep, something like this, right? And let's modify it a bit. So and then okay, we'll do that later. Let's for now make and make run. Okay, so we got some kind of error here, right? Mm, well, that's a bit strange. So let's look at it. So it says that we got some kind of error here. But like, in fact, if I just do this, right? If I just do this only, if I just do this only, in that case also, does it throw some error? In that case, in fact, it gets so somewhere in parse term, in parse term, we have, I mean, not in parse term, but in parse primary, I think, right? So where is parse primary? I need to check that. In parse primary, we have forgot about the parenthesis because it might be wrapped by a parenthesis. So else is basically this is easy. Else if current dot value is equals to this guy, right? This somehow we didn't bring out again. So auto node, the same thing, nothing so fancy. So auto node equals to ASP create node. Okay, actually, no, auto node equals to parse expression. I think we get the expression. We get this guy, right? We eat this guy as well, and then I return the node. I think that's all we need to do here. So let's check it out once more. 4 times. Let's say 1 plus 2, right? Something like that. And if we make this and make run, so yeah, we have first 1 plus 2 done. Then it's multiplied by 4. Then it's added to 2. This thing, which is our third parameter. whereas first parameter is this, second parameter is this, and third parameter is this. And these numbers are basically different because these are the like types, basically, whatever the node type is. Right now, it's just slamming this then like number. But if we just have a number to string lookup, then it makes sense. Yeah. So I wonder how do I remove this buffer? Because I would rather like to have this one side by side as well. So maybe the best thing will be to close this and open another one and go to cd sw spanning. And then we can say try Control Shift P. We can say duplicate pane Shift right. We can cd sparrow, right? And then we can have like two different strings, two different things done at two different places. But that's for some other time. Right now, we're going to do something more interesting. That is, we're going to have we'll extend our lecture to have more types of tokens. Okay, because now we will have if and these kind of guys, right? So let's do that. So let's go to lecture one more time. So lex, do we call it just lex? I guess so. So that is one thing. And we can definitely we have a different vibe going on here and different vibe going on here. But that's fine. It doesn't really matter. So yeah, let's add some new types, right? So we can have those extra types right here because those are basically some special kind of tokens that we want to support. And also, I'd like to have this little guy right here because we had added that guy there. So are there nine symbols? One, two, three, four, five, six, seven, eight, nine. Yeah. This I think is nine. So yeah. First of all, we'll have pk if, that is our if statement, right? And then tk while, which is our while statement. Because like for loop and those things we can have later. But if else and while these tokens we need right now. So pk else, and then we have the control flow changing things, right? So tk return, for example, tk continue, and tk break. Right, these guys we need it. And maybe you can also have like the basic types declared here at this point of time. So pk in pk not tk is there. So okay, we'll look at types a bit later. Okay, might be we can just have the whole typing system inferred. That might be a cool way of doing things. We'll check that. But what I want to have is pk false. Because false is a special kind of thing, right? Same goes for tk true, right? And also we can have pk like null. Okay. Because yeah, null is always good to have in any language, in fact, as a token. Right. So let's go with these guys first, and then always we can come back later. Right. So yeah, let's get these guys implemented. So here somewhere we are passing the ID, right? So when we are doing this, basically, after that we can have a check, and from that check we can determine that okay, this type of token, right? Let's quickly do that in a dirty way, maybe. So what I am thinking of doing is having a function here, right? Like Yeah, like in other places we're not doing this. So, and these are like in order. So let's just do not do that. Let's not do this all these things, and let's just mark them as static. Because why not? Then they are not going to cause any kind of error. So static and maybe static, because like I'm also streaming and doing this stuff at the same time. So I would like to have less amount of like declarative code as less as possible. But that is the reason. So yeah, that's fine. So we need to have some kind of a like ID checker, right? So something like void con, like something like void, something like static void which ID type, like ID type. So we have flex token here, so it should be below that. So so struct mm, void, not struct but static void. Let's token interpret T R N T E R P R E T, I think. I don't know. And it takes Lex token reference. So Lex token T reference token, something like that. And in this token reference, what we can do is we can say that okay, whatever my token is, so this token. Um, so if token dot type, right? This is not token dot type, but token dot value, right? This is equals to this guy, right? True. Then token itself dot type is equals to this, like tk2, and that's about it, right? And we can have a bunch of if else or a switch, but we are going in if else way, so I will keep on doing if else until like we really need to find a good scenario where like switch is needed. So yeah, else if there is a thing like half of the things even in C you can live without them. For example, you live with if else all the time, and you never might want to use switch. You can live with for loop all your life, and you never might want to use while, let alone do while and this was. So yeah. So pk dot value is equals to, let's say, false. Let's do it like this. Okay. Let's, because this is either way very small one line. So how about we do it this way? And then we have this guy that comes here. Right. So yeah, this is top. So top dot value is equals to false. When top dot type will also be pk false. Right. And we can have if else false. What is the problem? Use of undefined identifier false. False is here, no? Oh, right. So we have talk false now. Then we have, let's say, null. And similarly here we can have talk null, not nuke, but null. We can have a nuke token. um, so these are the for true, false, and null. Then we have if, else, and while. Right. So let's get them done as well. So Sorry, my bad. So if it's if, then it's tk if. Sorry. This is a good place to use Vim macros, but I'm a lazy person and I forgot the macro syntax entirely. So, yeah, else. So else and then while, if I'm right. So tk while. And one more thing, right now, like everything we're doing is mostly ASCII like. I know that, like, in fact, this will work on Unicode. Most likely, I don't know. This should work on Unicode because, like, but yeah, at some point of time, we explicitly need to check for Unicode terms. But like for ASCII characters, the Unicode values and ASCII values are same. So that's why I'm not worried. And they will always be in different bytes. So either way, for identifiers and strings, all we care that they can be Unicode. Maybe we'll see. TKY, right? And then there is break continue and this guys, right? So we need another three blocks maybe. So yeah, we are having a lot of keywords all of a sudden. So break, continue, and break, I guess, and return, right? Some point of time we need to keep on like adding explicit checks if all the enums are used. But for now, let's go with the flow, right? Break and while, right? So next what comes is implementing these statements like if else and these other kind of statements, right? Because now we have them in fact as our tokens, right? So yeah, one thing I would like to have is let's say examples on demo, right? So in demo we had this. So I want to also check like printf. Like for example, if I have something like this, forget about this thing. But if I have something like this, print whatever my array is, it's second to fourth element, something like that. Second to sixth element. Is this a valid statement? Yeah, it obviously needs this guy. But is this a valid statement? So you can check that. You can make and then make the run, I guess. And see, it's an array with access operator of these two, and we have some like subscript operator of these two, and then we have print, where we basically have a function call. Okay, and yeah, we have one redundant node maybe. That this one I need to check. What is like for example 17. No, okay. So okay, got it. This is like rent itself, right? Is taking an argument list. So this is the argument list, right? And in the argument list itself, there is this subscription operation that is going on. And in this subscription operation, we have first of all the guy that is being subscripted, that is arrow, and then this guy, which is basically saying that okay, you're provided a subscription list, which is this, right? So yeah, at this moment we already have something that C does not have. Right. C has a different way. Trinary operator. We'll have trinary operator. Okay. In fact, so that we have that scope of having trinary operator, let's add this guy right here, right now, and let's make this 10. Okay. So yeah, but I'll implement that a bit later. Right now, I am most interested in implementing the if else statement, right? Mm, and just to have a brief overview as to how much time has passed, it's around 1 hour. So we're actually doing quite much progress today with not that much like getting into the debug hill. But yeah, debug hill will come soon. That's how typically programming works in general. So we will face the puzzle at some point of time. Uh, that being said, just let me think a bit. Okay, just now we are going to introduce this if else statements, right? If else statements and while statements. So they will probably go in parse statement itself, right? Parse statement is going to not just going to be like parse assignment, right? It's going to be totally changed, but that's fine because in all these construct, if you see, you will have something which will be followed, right? In case of if else and those guys. So just give me just let me think a bit. Okay, if else and for while. Mm, so how about this? The statement itself can be many things, right? It can be a statement. It can be an if statement. It can be a while statement, or can be a block, right? It can be an assignment or an expression or a block. How about that? So if we have something like this, right? For now, so is the not the pointer parse if so statement, and for now it will just return null pointer, but that will change. And similarly, we have something like uh parse let's say while statement, right? And then we have like only these two ways for now, right? So in a statement, we can have this thing, right? Where every other match fails. But if we get something like an if, it froze, I think. Is it frozen? No, yeah. So if let's say if current dot value is equals to in fact, or we can just use current dot type because why not? We don't usually use type quite a bit, so it's fine. Okay, if right. That means we are in a if statement. So we would probably like to return an if statement. So parse if statement, right? Else if current dot type is equals to let's say pk while, right? In that case, we'd like to return a while statement, parse while statement, right? But just let me think of it a bit. Else, else is this thing, right? But apart from else, we can also have a scenario where we can encounter a block inside a block, right? And that is not treated here because this block is basically the very outside block. Right? So we need to have something like an inside block parsing as well. But when we do block parsing, right? Block can be a single statement as well, right? That okay, we'll see. Right now, you can see later. Yes, it will be parse statement. So I can check that later, right? So basically, else if current dot value is equals to this guy, right? Because only for this guy I will be calling parse block. So I'm very confident that we will in fact get a valid block. If that makes any sense to you. If not, that's also fine. So return you aren't, if I can spell it correctly. So we're going to return parse block. And that's the beauty of recursive descent parsing. Like when you get to that position, it becomes very easy to add new constructs to your language itself. Um, yeah. So, and if all these cases are not true, right? So else, in that case, we go for our classic, this guy. And maybe you can just get this formatted a bit. And yeah. So if we get a if, then we return an if statement. If we get a while, we get a while statement. We return a while statement. If we get some kind of a block, we return a block statement. Where inside that block statement itself, you can get into some other block and so on. I guess, yeah, because we have this first statement, right? So I don't know how it will play out. You can check that later. Because parse statement at the end of the day will invoke a block, right? So inside this parse statement, a block if exists, it will invoke another block parsing and so on, so on, so on, and that will go on. So yeah, we have nested blocks now. In short, now as far as the nested block implementation goes, this looks absolutely fine. So let's go with if statement, right? If statement, we encountered a if. So first of all, we will okay, and we know that it's an if token, so it's fine. Then if we will need for now, let's keep things classic. We'll eat this. I want to like keep it as much as C like as possible. Then we can have maybe a node so expression. And by the way, in C++, whenever you are absolutely sure that this particular function call or this particular variable is going to be returning a value which is of type this and this type, no, not this, but like type X or Y or Z. And I know that type X, Y, Z is absolutely has no ambiguity. I can use this keyword auto and it will deduct that type for me, right? So it allows me to save some typing. So first of all, in an if statement, we'll have some kind of an expression, right? So expression or expr is equals to parse expression, right? If I can spell correctly. So parse expression, and in this parse expression, we parse so nothing, right? And then we simply eat our favorite snack, right? Which is this guy. And once that's being done, then we parse a statement, right? Because as we remember, a statement can also be a block, right? So that will come here handy. So basically, auto if true statement and like each statement is equals to parse statement. And then once that is done, then we can have multiple else followed by it, right? So that you can check, right? So while let's say current type is equals to k else, right? As long as we keep on encountering pk else, okay, we can eat that else. And we can have one or more else. So even if we don't have any else, it doesn't really matter. In fact, we can create our if statement right here. So something like let's add those types as well while you are at it. So what did I do? Hmm, yeah, that's fine. So is the now we have our new kind of statements, which is the if, then is the mm, 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 else. I don't know. Like we'll check if you need else. Is the while, is the return, is the true, is the false, is the like, true false. True false we'll do later. But let's have HT continue and HT yeah. What is it called? Mm, Return continue, HT break. Right. Very okay. If I can spell correct. So yeah, these are our new HT types that we can introduce. Right. So we have our if statement, right? Auto if node is equals to a is the dot create node, and the node is of type ast if, right? And we're going to basically return this if node. Return if node, right? And in the here we have if statement, right? So if node will first of all have its expression. If node will always have its expression. There is no doubt about it. So we can say if node children dot push back. And here we have our basically expression, and then it will also always have this statement with it. Okay, no matter what. So if node and followed by like children, if I can spell correctly. If node children dot push back if statement, right? Or the true statement. We can call this true statement. Or if statement is fine, right? Right. But if we get an else, right? So most likely what we need to do is we need to create an else block. So we can have redundant like child how do I say it? Like we can have a like redundant hierarchical nesting, but that's fine. So auto else node is equals to ast dot create node ast else, right? And then auto statement, mm, whatever that comes after that else node now. So that is a parse statement basically. So parse statement. This is parse statement, parse statement. This is parse statement right here. So parse statement. And then else node, if I can spell correctly. Children dot push. What is happening to my typing? It's already slow now. It's becoming much more slower. But yeah, if node children dot push back once node, I guess. Yeah, that looks correct, I guess. And then once we are done, right? And this will keep on going while we encounter an else block, right? And we eat that else block and we do all stuff, all kinds of stuff. And at the end, we are done parsing with the if statement. Yeah. That's how cool is that, right? And now let's go with the while statement, right? So parse while statement, right? So this is kind of similar. In that sense, it's just auto while node. Or we can just simply say node equals to ast dot create node while ast while, right? And we can eat the while statement itself, and we can pretty much do this whole thing, right? Because this is common, right? No matter what. Getting the basically condition itself, right? Um, So, uh, yeah, why is that happening? I think this is the right. Okay, why are we doing this manually? So this is not okay. And another thing, let's format this while we are at it. But I think I'll call this condition rather than if node. I'll call this expression. Oh, this is pushing in if node, so that's fine. So like I don't know. I don't want to like allow all the expressions. But yeah, let's see. We can always come down to condition so that like I will do I want to support assignment? That is the question that I am trying to find the answer of. We'll see that. But essentially we have our condition pushed to a node and we will be returning our node. So the next is to get a statement, right? And while in fact if you remember you can have a blank statement as well, right? So it might not have a like statement at all. I'll just like to quickly handle it here. So if let's say current, mm, it throws or what? I think I pressed current. Yeah, current dot value. This thing is equals to this. Okay, that means we are trying to create an infinite loop. In this case, just eat and return node. Right. If that's not the case, then just whatever statement is, right? So statement equals to parse statement, right? And then node children dot pushback statement, right? And then at this point, I can return it, right? But I want to have an else, only one else, which is not there in C, and there is no need for it to be there in C, but for like while I actually like in Python we have an else block attached to while loops, and it's actually very helpful in that sense that in some cases we want to execute some code when the loop in the while is not executed at a single time, and for that I have to nest that while inside an if statement. But if I can attach a while directly to the like if I can attach a else block directly to the while statement, then effectively I can like remove one nesting altogether. So that's the idea. So we'll say if we have something like current dot value. So this is while you see because we can have multiple else's, but here I will only support one else. I'll not like support multiple else. Okay. Actually, this can also be if. right. And so effectively with while also, I can get something like while else kind of scenario, right? Which will be very devastating. But yeah, we can see like what kind of artifacts it brings, and then based on that we can quell down its anger. Okay, because like in else we can have a statement, right? And this statement, like after else, I'm saying that I'm getting expecting a statement. That statement itself can be an if statement. So in case of while also, only if I get else, right? Then I can attach a statement, and that else can be an while statement. So yeah, that's cool. Like while doing this, if this does not happen, then while keep on doing this. That actually might be a nice thing added to a language maybe. So if current dot value is something like not current value but current dot forget about it. We just need this thing, right? Let's copy this guy. Let's paste this guy. Let's forget that this guy ever existed. Let's get this thing formatted a bit, and then let's attach this else node to our node, right? And so now effectively we have, I think, if and while statements. So it's time to check it out and fail miserably, but that's part of the whole game, right? So let's do it a simple thing, right? So if x, let's say if x equals to 100, right? Then maybe return. We don't have return right now. So print f, let's print hello. Else if x is less than x is greater than maybe 50. Why am I even trying to add some logic? Because at this point of time, logic doesn't even make any sense. So print hello 2, and then else maybe print else. Right. We just keep this thing. And then I have like something like this. If x is equals to 110, then print hello world. Something like that. Okay. Small w. If I then make will run, but make run will run yes or no. Okay. So we got something like this. Oh, we got some exceptions. Expected this at line number 2 here. Why did you expect semicolon? Okay, this will check. Um, and the same goes for line number 4, right? So in every um, if statement it expected a semicolon, this will check, right? We shouldn't get this error. But in fact, you can see that we have a statement, right? In that statement, we have a if block, right? And in that if block, basically we have this condition, right? We're checking this condition. We are having some redundant blocks that we need to check. But if this condition, after this condition, right? Basically we have another block here, which is not right. So let's remove this thing for now, and let's understand where we went wrong. Right. Welcome to debug 101. So and yeah, when the debugging starts, everybody runs a. So you have first a block, right? A basic block where everything is there. And there is a statement, and this statement is of type if statement, right? So why is if here? That is also a question. Okay, well, let's go one by one. As far as the tokens are concerned, right? If the tokens are correct coming correctly, that is a question, right? So we have okay. So one thing I think I forgot is to call that thing in Lexer. We made that function, this thing, Lex token interpret, but we never called it where it needs to be called, which is right here, right? Not here, but right here. So we need to call this guy, and we need to call this guy on this last token. So basically, whatever tokens we had, right? We think I think tokens dot net. Yeah. Now if we make and run, right? Oh, that error is actually gone. Okay. So we have this block, right? And one more thing that I would like to have, like for if node, right? So I would like to have the value. So if the value is equals to if, so that we can at least get some clarity as to what is going on, right? And same goes for while, like else node. In else node, I would like to also have the value, like else node value to be else. Yeah. And for while node also, we would like to have node value to be while, something like that. Uh, 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 yeah, and the rest is fine because in case of block, we already know it's a block and statement, first statement, so on. If we make now, if we make run, right? So yeah, we get this block, right? In our root program, we get this block, and this block has an if statement, right? Direct here, if statement, where there is a condition, and the condition is this, right? Because if statement's first child is always a condition, this condition, and then followed by this printf guy, right? So then there is this statement where it's basically printing hello, right? If that's not the case, right? So this if you can see, its second child is this if else statement, and just like as we expected, else has a child, which is this else if statement, right? This is how it's actually done in C. It's not how it's done in Python. That's why they have this elif kind of thing. But in C, this is how if else works. If else works, and we can also have something like this nested ifs, right? So just to check if okay, this looks kind of crazy. What will it succeed or will it fail? Okay, this one we need to check why is it trying over this thing. But hello to will fail. Make run. Line number 5 here. What is it saying? Expected. Do we not support for and? If we have this, maybe we don't have support for and. That might be a scenario. Um, yeah, we don't have support for and. That we have to check. Logical operators, I think we haven't added support yet. But yeah, we have this if statement, right? And in this if statement, we first print hello, And then after this statement of printing, there is another if statement where we print this hello and then this thing like colon. Even the smiley will now work here, if I think, right? So if we do that, and we make run, right? You get this smiley, right? So our language is actually becoming quite robust, right? We have all this nice things, right? And so maybe it's time that we add the and operator and or operator, which will be actually very easy to do if you think of it, right? So let's do that. First let's check in our AST, right? Okay. Before that, first check if we have the symbols here, right? So we don't have the symbols, right? So we not we need the no, we have this symbol, right? This is the or symbol and this is the and symbol. But like in modern C++ also, and is totally fine. So do we have to have the symbols for and or we want to have the symbols for something else? Because like this is due to some legacy reason that mm, like, okay, but our syntax is nearly to C at least, with a bit of Python Sparkle that we have introduced today. Let's not go over there. Let's go to somewhere else, and that somewhere else is let me think. RAST, right? Yeah, I got a like if statement and like all these things done. So I'm getting a bit like out of the zone at this moment, but that's fine. Um, so do we have and do we have and I don't think so. I don't think we have and, right. So right before assign, right here we can have something like AST and AST or, right. For now, let's have and or. Okay, there is redefinition. There is redefinition. So somewhere we have and or defined, and that's good. All that matters is that we have it, right? So in my eyes, I can see and, but if it's saying that it's already okay, here is the and not, right? So let's get and not done, right? So let's look at our rough, okay, because rough contains our precedence table that like, I keep on forgetting, right? I can't remember the precedence table always, right? And at some point of time, we need to also support tuples. So that also we will check, right? How we can support tuples because I want my functions to be able to like output tuples. Otherwise, there will be no fun. But we will get to like getting at least some kind of compilation done before we start implementing functions because like functions and structs and those things they need some special care and maybe I need to read a bit before I start attempt like I start attempting to do those guys, if that makes any sense to you guys. Yeah, but that being said, and we will have a lot of validations layer like parsing does not 100% guarantee that whatever the AST or the syntax tree we're generating is a valid syntax tree. So we have to have some kind of a validator step after parsing, so that we can essentially make sure that we have that thing. But that being said, let's get started with adding the missing things, which is actually going to be very easy, I think. So yeah, as you can see, we have first logical and then logical or, right? So these two are different, and let's do we have bitwise and bitwise or we can do later, right? But essentially they come after our comparison stuff, right? So they come after compare, right? On an equality. So we're done with equality. Now we are going to do the logical and logical or basically, right? And the order is first we are going to have and, then we are going to have or, right? And can you believe it? Like in this single file, um, while doing stream. we wrote around 500 lines. So first one is parse and, right, and so that we look a bit like civilized people. I don't know, like writing logical and makes people civilized or not, but hoping that it makes, because people can always hope to keep their dream alive or whatever. I don't know, and I don't. Do I care? It's a good question. No, I guess. With that being said, this thing should be pretty much simple. We don't need this if statement. This can be AST right, and this can be or and symbol, right? Or you can just have current everywhere rather than typing this thing a lot. That's fine. Because after that we eat, right? Before here we don't eat. So maybe just to save time, I can just make this as current dot value, right? So let's format this bad boy. And before that we need to change parse compare to parse equality, right? This one also needs to be parse equality. And I am actually quite getting quite used to using them doing this exercise. So that's nice. So we have parse logical and where we basically parse equality. And while we keep on getting and symbol, we do that same hanky panky that we usually do, and then we just return it. Why not? Copy this. Okay. This is capital AST and, right. Copy this. Paste it here. This is logical or, and this is parse logical and, right? Because or comes after and, right? If you remember, we're having a lot of things done today. If you think of it, at least we have a very good kind of language parser, or like what people like to call these things, like AST and the like if we uh, when we'll have like much more files than just a lexer and AST and a parser, and we will need to like hierarchically arrange those files. Okay, although like in my personal opinion, I don't like to like get into too much hierarchical depth of folders. Okay, that makes navigating a bit much more time consuming for me. But like if we have to like hierarchically arrange our code base, it will look something like this. We will have something like a front end. Like this is how it's typically called, I think. So in front end you will have something like your lexer and your parser, those kind of things, and your ASP and so on. Right. Maybe your symbol tables, something like that. And then you will have your backend, right? Something like that. And backend will basically take the outputs of front end from different stages. Specifically the AST and the symbol table. And it will have something like IR generation, then maybe ASM module where we are getting the assembly, and then finally the compilation unit, or maybe the interpretation unit. Right. So, yeah, that's how the typical project structure should evolve, right? And I'm still debating like whether I should have an interpretation unit and compilation unit. And in my compilation unit, do I really compile from assembly? Like I write as a generate assembly, because generating assembly will be much more harder for me. I'm not that like I know a bit of assembly. I know quite a good amount of assembly, but I'm not used to using assembly. So it will be much more harder for me to like, do the assembly stuff, compilation. But also like the optimization part that comes, right? But an easier way will be to like convert our whatever our source code is to something like a C code, and then we use a C compiler to do the compilation to machine code. Okay, that is actually performance wise superior, but from the streaming perspective, that will be a bit counterproductive, because I want these streams as like as well as for like me doing some small work for myself, and exploring stuff. Along with that, I want these streams to be something that is also helpful to people who just want to like go out of the comfort zone of beginners friendly tutorials, right? Where people can understand and relate to like things that are a bit more involving, a bit more engaging, because that kind of videos I don't find in YouTube. I find some of those that kind of videos in YouTube, but they're like too much choreographed. They don't show the what really happens when you're like, working and you're trying to develop a software. So from that point of view, this kind of rambling comes. So you can ignore this ramblings, and we can continue on the or, right. That is more productive, I think. So yeah, or, and at this point of time, we can finish the bitwise and bitwise or as well. I am thinking. Just let me cook for a bit. Um, yeah. So we have parts logical and parts logical or, right. And with that, what I essentially want is to get that earlier error that happened to go away, right? And so right now, what we actually written is logical or, right? So let's go up. Let's check whether we are actually returning logical or in parse expression, right? So this is a good time to do some finding. So parse expression, right? Wherever its occurrences here. So instead of parsing equality, now we'll parse logical or, like that. And with that, I should be able to do this, right? Let's forget about all this junk for 1 second, and let's concentrate on one simple thing. I need to do something for this setting. It sometimes annoys me a bit. So y equals 20. Now, does it support this expression? Let's check. So make run. Right. So yeah, we have at the top level and operation where we have two equalities. One is equality between x and 100, and equality between y and 20, and it's working. Nice, isn't it? It came so far. Anyways, now comes the few control statements that we earlier missed. Sorry, not mixed, but missed. And they all go in parts term basically. Like parts term or parts primary, whatever you're calling it right now. So, like if I were using something like VS Code, which I'm more familiar with, I would have been like much more ahead of where we are right now in the same time. But sometimes it's not about just getting the things done, Sometimes it's just about enjoying what you're doing and putting yourself in uncomfortable positions so that you can better understand what your strengths and weaknesses are, right? So if we have a token of type, let's say mm, return, right? So probably we would like to return a AST return. Don't we have a AST return? Okay, we need to add a AST return. Oh, we have a AST return, right? And if we have a like break, then we want to return a AST break. And like we'll keep on adding stuff. Okay, but probably in the next one we will go into a bit of higher generation because we have some boilerplate code that we can work with, and then for functions and those stuffs we can like once we're done with this basic things higher and maybe like actual code generation, we can come back and we can add functions like function declarations and all other stuffs, right? We can go one more round on AST on this. And yeah, I'll at some point of time, like after we get our basic program done, I'll also get back to that editor that we were doing because right now we have the individual components, but the editing is not still there. So yeah, one day we will sit with that and we'll look at the rendering things a bit also. Okay, it's not that I am leaving it away. I'll I'll get it to working. Okay, to a working state where people can use it. Okay, it might take 1 year. This might take 1 year and more. But you will have a journey of your like you will have a journey of product being developed from scratch. Okay. Um, at first it's just exploration stage. Like both of these projects, that text editor and this language development, these are in exploratory stage. But from this exploratory stage, we will be going to like for example the stage where yeah. So we have break and then we need continue. Like actually where you feel confident that no, I can take C++ and I can or any other language, Python or anything, JavaScript. We'll do some Python JavaScript in future as well. And I can build shit out of things. Right. That's one thing. The second thing is that like we always eat at the end. All right. We always eat at the end. So rather than doing this stuff right here, I'm doing just a bit of organization, nothing else. We can have something like new OP, then value is equals to current dot value, right? This is much more generic, and because this is much more generic, we can keep on abusing this everywhere, reducing some at least some line of code from like our code base. Right. For example, here, like we'll have like four interlines vanished just like that. Sorry. Uh, and still, everything will work. And at some point of time, we'll also need to introduce like unit testing, right? So just to be sure, right? Do we have a break here? Um, let's just check that really quick. But every part is working. Yeah. So we have a break statement, right? Yeah. Look, this is a good place where you can leave, but let's push a bit more and let's get this thing done. Like really done, kind of done, right? Mm, so yeah, we need a couple of more things like bitwise and bitwise or and bitwise XOR. Bitwise XOR is a very important. Exclusive XOR is very important. This is what makes many cryptographical algorithms possible. Okay. So enough about the kind of ramblings I does I do often. And let's go back to ASP and add those things. So we have and or and these guys, but after not equal to, we might want to have ASP bit or ASP. Like, let's do it this way: ASP bit and ASP bit XOR. Right. These three guys. And these three guys are actually pretty cute, in my opinion. I don't know. But even we can have a templated functions for these alls, right? And then we can call that templated function every time. Okay, let's open our precedence list so that we don't stray away and then bite ourselves back in the foot, right? So as you can see, bitwise and like after equality, right? This all happens after equality, right? So once this equality is done, then instead of logical and, we will have like bitwise and. So this will be bitwise WISC, right? And so bitwise and is simple. It has only a one and symbol, right? This is bitwise and, right? And it will just come after like this guy, so we don't have to do much thing. This is AST bitwise bit and, right? And same goes for, let's say, bitwise, if I can type correctly, right? Then comes the bitwise like XOR, right? So bit XOR, right? And it parses bitwise and, in fact, and bitwise XOR is this. We don't want to have a power operator. That's fine. Like in Python also, like we don't need this. Like we can have double star for power operator if it really comes to it. Because right now we are not looking at references as and pointers. Some point of time we will look at them, but not right now. Unless we get to the function part where it's important to get data duplicated and those stuffs. Till then we can just ignore. And also there is one more kind of data structure that we are not still handling, like array assignment, list up assignment, and like tuple assignment, that kind of thing. Like array assignment or like initialize a list, for example, what is in C++. So that also we need to handle at some point of time. But that can come in fact later. Right now, let's stay simple. And once we are at that point where we can push, we'll push as hard as we can. So like I could have stopped here as well, but I'm still pushing, right? I'm going to add these missing operators because I hope to finish these projects at some time and finish them in such a state that they're usable to people. Now, whether people want to use them or not, that's up to them. It's not for me to decide. But I want to make some projects that I wanted to make always, but never got time. So bitwise, I think Zor, I think, right? Because this comes after Zor, right? And then I can just plug in this bitwise or in logical and we'll have the complete picture. right? So everything is fine. This is just a bit off, right? And here this is bitwise XOR. Um, yeah. Then we can have in the here instead of parsing equality, we can have bit parse bitwise or correct. I'm not going to check this because I know in fact that this is going to work, right? We have done this so many times. Probably should have created some macro or some template function to do this, but yeah, we will do that at some point of time, maybe. If, if like when the more constructs will come and this will become too much. But for now, it's fine. Maybe we can keep a part of this code in a separate header file as well. I don't know. Like up to 3,000, it's comfortable to me. After we cross 3,000 mark of like 3,000 lines of codes, I think that it's about time that code should be splitted in multiple modules because then like it will take me much more time than like let's say 10 or 20 minutes to understand the module when I come back later. Okay, whenever you're writing a code, you need to make sure that at least you or some person who is coming back to the code should be able to understand the code. So one way of that will be like flooding your code with a lot of comments that I absolutely don't like. Okay. But the other alternative that I like is to have not too much long names, but not too much short names. Have some good in between where it's easy for some person to like understand and go on understanding things as long as they have the general idea of the concept itself, right? So that's what I try to achieve, right? And yeah, like that whenever I'm creating node and these things, these are pretty much how a recursive descent parser should follow. The same goes for when we are writing Excel, right? So like adding a bunch of comments here and there, here and there, here and there does not make any sense, right? And for the small like 4 or 5 lines of smart code, that is understandable. But still, if you have like 4 or 5 lines of really smart code or one like super messed up comprehension, list comprehension of, for example, Python kind of list dictionary comprehension mixed up, then probably you should add a comment, right? Or like if the whole objective of the huge function is something that you want to declare upfront, which is not visible directly reading the code, then there it makes sense to add some comments. But otherwise, I and yeah, another good place to add comments is when you're using some AI agent to basically edit your code. But yeah, in that case also you can pretty much get by without comments. In fact, like comments, like the kinds of comments that present in the code is a good indicator of like who has written that code itself, right? And yeah, like if I get someday some like permission from my company that then maybe we can add like and full like cursor or like copilot like code editing system to like our editor itself because I know how to do that. Okay, all you need to do is do some vector indexing of like chunks and that's it, and then add some like vector search kind of agentic logic, right? And you can get an cursor implemented. But yeah, that's about it, guys. I think we had done a lot today. I'll just make sure that everything compiles and runs, right? And we can start from where we left, right? Mm, on the next day. So the last thing that I maybe like to do is go to main, all right? Because we will be jumping to the next stage of our this programming exercise. I'd like to have this file get taken from argv. Okay, so We'll have something like this. If argc is less than 2, right? Less than 3, right? Or less than 2, actually. So we want to have something like printf um, usage. Right. This is how basically you use Sparrow, right? Um, Later we can have like much more difficult things, right? But for now, right? I don't care honestly. So file path is just for now argv1, right? And this is for now is not equals to 2. So I strictly expect that you provide one argument to me, that is the file, right? And that has to be an external file for now. Later we can have an arg parser which deals with different kinds of arguments. In fact, we will have that when we actually think about like we add module import and those stuff. But that is for a future point of view. So with that, now this file is supposed to be passed to the make file via this, right? So the benefit is that no longer we will need to compile Sparrow again and again and again, but rather we will be able to like pass the file directly from here. So example slash demo dot Sparrow, right? So that will, in fact, I think if we make, right, nothing breaks, and if I make run, this is it. Now, if I say that, for example, x equals to 20, that 20, right? Only this. Yeah, we need a semicolon. Mm. And we say just make run, right? So it will read that file and do its stuff. So yeah, that's it for today. Hope you enjoyed this video. If you enjoyed this session, please hit like and maybe share this video with some of your programming enthusiast friends. But I know that if you're watching this video, then probably you don't have anyone with whom you can share this video. But yeah, hope it helped you to learn something new. And see you next time. Till then, enjoy your days. And yeah, like always enjoy your days. But yeah, till then, have a nice time and bye.